6 gigahertz is launching out of the box with the new K-series processors that are launching today. I've got the i9 and the i5 right here, the 14900K and the 14600K, but also coming is the 14700K. 8 performance cores, 16 efficiency cores for the i9, 8 plus 12 for the i7, and 6 performance cores and 8 efficiency cores for the i5. It's a new configuration for the i7. They all have a few hundred megahertz clock bumps, but the i7 was the most significant upgrade over the prior generation, but more on that later. Gordon from PC World was right at Computex. It was like, just a few bumps. Meteor Lake, same as 13th gen. 14th gen? Okay, it's a refresh. Meteor Lake refresh. Improvements in process technology and packaging mean that these CPUs can consume more power and deliver that power into more heat, but also more clock speed. So Intel definitely is the undisputed champion of 600-watt desktop processors. Okay, I'm exaggerating a little bit, but they are delivering the highest single-core clock performance that I've ever seen anywhere. These CPUs are going to love liquid nitrogen. I can't wait to see what the extreme overclockers do with them. But why call this 14th gen? It's literally 13th gen with a refresh. 13.5 gen maybe? Well, the short answer is probably 14th gen sounds better. The long answer is this is probably the pinnacle of lightly threaded desktop performance that we're going to see for several generations because of the changes that are coming in packaging and process shrink and everything else. But first, let's unpack and see what we're looking with now before we get into this crazy speculation. It's the Spider-Man meme where they're all pointing at each other, and this is the third CPU release that fits in an existing LGA 1700 motherboard, which is highly uncharacteristic for Intel. I mean, upgrading from 12th to 13th generation was, minor, but the processors were different. Now we're upgrading from 13th generation to 14th generation. I mean, if you look at the 12900K to the 13700K, 8 performance cores, 8 efficiency cores, and yet when you peel back the hood, it's like, oh, okay, there's more than clock bumps here. There's also some cache performance, and the memory controllers may be a little bit better, better assembly, but not quite the Spider-Man meme that we have now. Here, it really is just Meteor Lake again for 14th gen, but it's a refresh, and so those clock bumps come from improvements in processes, and maybe they were holding back some previous 13th gen processors because they did really well. I don't know, but at the bleeding edge, you're basically on a tried and true platform, which is pretty awesome. Think about it. Board manufacturers are on their second or third revision of Z790 motherboards. They've already got a lot of QA time. Their BIOSes are very, very polished at this point. DDR5 memory has come a long way since the initial Z690 chipsets. I mean, DDR5 it's pretty pedestrian to get 4 sticks of memory working on an Intel platform. And DDR5 XMP, making the memory run as fast as possible. DDR5 5600 support out of the box, but I tested 6400 all the way up to 7200 with 0 issues. And if you know me, you know I trip over a lot of issues all the time because I sort of poke at it in strange ways. Plug and play. 14th gen gives you plug and play DDR5. One of the biggest challenges that you're going to face building around a 14th gen processor is cooling. We use a Liquid Freezer 2 with 420 millimeter, but that's a cooler that you can buy with confidence for 14th gen stuff if you're going to do anything because it does as good a job as anything. And why I think that this is probably going to be the pinnacle of desktop performance is because what's coming in 15th gen and beyond is new packaging technology and a whole bunch of really experimental stuff. If you are normally somebody who buys the thing that's stable, it's once in an age that you can buy the new thing at the bleeding edge of performance, but also, almost paradoxically, made with tried and true parts for stability. Because this isn't a new socket, and it's not really technically a new processor, but this is the highest gaming performance and desktop clock speeds available. So, if you're already somebody that only buys things that are tried and true, this is the buy for you. Let's get to the performance breakdown, and keep in mind that this is the exact same system we're testing between 13th and 14th generation. We're literally only swapping the CPUs. We're definitely underscoring the fact that this is a refresh. All right, so for benchmarks, I'm being a little bit of a terrible human being here for comparing this to the 13900K. It's really 13th gen versus 13th gen, although I did go with the out-of-the-box defaults for the 13900K. That lets the CPU boost however it can at the default power limits. All things being equal, the 14900K is a little bit higher clock speed out of the box, and it will consume a little bit more power if your motherboard lets it. Not all motherboards have the appropriate current limit to let the 14900K do its thing. So you might want to manually dial in 400 amps for power and then just keep an eye on your temperatures. That said, Assassin's Creed Mirage with the 7900 XTX, we are not off to a fabulous start here. This is basically margin of error territory, although our 1% lows and our 0.1% lows are a little bit better. Now, Intel tells us that they have made some adjustments to Thread Director, which benefit all processors that use a mixed performance and efficiency cores topology, but these were tested at the same time. So we could be looking at a 13900K that's benefiting from the Thread Director that has been improved, because these were tested hours apart. It's the same kind of story at 1080p. We're looking at 140-ish frames per second average, but the 14900K does pull a little bit ahead. And we can see in Hardware Info 64, we're boosting to 6 gigahertz. This was not an overclock configuration. The 6.1 gigahertz overclock came later. Again, basically identical performance with improved 1% lows at 1440p. Borderlands 3 maybe starts to get interesting. We move from 30 FPS at our 1% lows to 40 FPS. This is just Borderlands 3 things. But that's an improvement. It's just barely outside of margin of error. At 1080p, 258 versus 271 with about 7 FPS better for our 1% lows. Again, a pattern emerges, but it's not a dramatic difference. The performance is within margin of error for the Callisto protocol. There's really not anything that stands out for the Callisto protocol overall. Cyberpunk 2077 without ray tracing, because I'm on the 7900 XTX. The 4900K does pull ahead a little bit. Cyberpunk really likes the single thread, clock speed. We can also see from monitoring the background tasks that Cyberpunk really doesn't use the efficiency cores. And when it does, it's probably not good that it's using the efficiency cores. Just Cyberpunk things. For Horizon Zero Dawn, we see the biggest difference between the 13900K and the 14900K at 1080p, where we're running at over 120 FPS. At 1440p, the differences between the processors sort of come together. This is an interesting one because at 1440p, the 7900 XTX GPU is only about 70% utilized. I mean, it's 1440p, it's kind of a middle resolution. The CPU is not really super pegged either, but the difference that we saw at 1080p is basically all gone at 1440p. Shadow of the Tomb Raider at 4K with the high preset, basically identical margin of error performance between these two processors. I mean, the 4900K does consistently pull slightly ahead, so there's something to that, but it's not a dramatic difference. 302 versus 299, we're breaking 300 FPS at 1080p in Shadow of the Tomb Raider, which is a big deal, but 266 versus 264 at 1440p. Resolution overall doesn't really seem to make a huge difference for Cyberpunk 2077 either. We're still at around 60 FPS average at 4K on Ultra, and that is with ray tracing. Our out-of-the-box scores were about 929 for single thread versus 893 between the 14900K and the 13900K. I could get 975 with the overclocks, which bumped, I think, the cache and ring voltage and the ring speed and the cache speed, and it also bumped our overall maximum clock speed to 6.1 gigahertz. However, cooling this was a challenge, as I mentioned before, even with our 420mm Arctic Liquid Freezer 2. In Firestrike Extreme, you can expect a few thousand point performance bump overall. Not bad. Same story for Firestrike Ultra. Definitely Firestrike benefits the most from the increased lightly threaded speed because of the lower resolution. The GPU is really not the bottleneck here. It's really more on the CPU side. And with the base version of Firestrike, the better it fits in CPU cache, the better time you're going to have. For Geekbench 6, we've also broken 3,000 points for single thread. This is a watershed moment. 3,000 points single thread, Geekbench 6, pretty darn good. For creator workloads, Puget Bench, you got 24 efficiency cores. That's where you can really leverage your efficiency cores. You've also got Intel QuickSync, which is no slouch when it comes to pretty much anything you want to do video encoded or video task related, especially with the Adobe suite. And this is a pretty decent uplift in performance. I mean, 1132 versus 1108. Again, if you're on 13th gen, you're not going to want to upgrade. If you're on 12th gen, you're probably not going to want to upgrade. But a Premier score of 1132 for a desktop processor with 96 gigabytes of memory and 2 sticks running at DDR5 6400, it's a pretty good score. For Time Spy Extreme, well, we've broken 14,000, almost 15,000 points in our overall score. going from 13723 to 14901. Not bad. V-Ray also breaks 40,000 points. So overall, I mean, we're talking about a desktop processor, and it is a desktop class processor. It's enthusiast class, but it's not high-end desktop, and it's not any of that, but it's 24 cores, and it's performing like a workstation CPU from just 3 or 4 years ago. So if you buy a workstation and you expect it to last 5 years, it seems like you're better off buying a workstation about every 2 or 3 years. Like maybe you get a 12th gen Intel CPU workstation, although the 12th gen was only 16 cores, 8 performance and 8 efficiency. And Intel really did something amazing when they went to 8 performance cores and 16 efficiency cores for that creator workstation scenario, because you've also got quick sync on top of that. And the fact that you can run north of 300 watts through that LGA 1700 socket, it's not bad. I also like the fact that the pricing fluctuates so much. Like what is a sub $1,000 processor today, in just a year or two can be less than 500, sometimes less than 400, which is a pretty big movement in a pretty short amount of time. Now what's happening during the benchmarks from a power consumption standpoint is perhaps a bit unsettling, at least with the 14900K. My CPU peaks around 96 degrees C, even with that liquid Arctic freezer 2 from Liquid. 330 watts as reported by Hardware Info 64, which is a significant bump over the 283 watts previously. Now the Intel XTU software has also had some dramatic improvements for 14th gen. They added an AI overclock tuner, and yes, this benefits everybody. You can run this on non-14th gen CPUs. And with that, I was able to achieve 6.1 gigahertz. Interestingly, the out-of-the-box performance of the 14900K for single and multi-core performance, I could do it lowering the power to 260 watts, 270 watts. Consistently, that was only about 5.7 to 5.8 gigahertz, but the performance numbers were almost identical for the out-of-the-box performance. The XTU option, like if you're thinking, I can do undervolting, Intel also introduced an option you can turn on. There's undervolt protection, because undervolting can introduce some sort of weird instability, especially if you're using the auto overclock tuning utilities, and it can also be used to compromise the system security, system integrity, but that's perhaps a video for another day. And this is where it maybe does make sense to get one of the refreshed boards. Many of the updated Z790 motherboards coming out are designed to deliver the new up to 400 amps of current that these highest end CPUs are thirsty for. I don't think that you really need to do that, but if you want to push it to the absolute limit, you can. But the fact that the CPU runs fine from 200 watts and change to 325 watts is very interesting. In other words, out of the box, it seems like Intel doesn't bother trying to optimize the CPU for power consumption. I guess they figure most people don't care. And they rely on their thermal protection and other stuff like that to keep the CPU performance and heat envelope from causing problems or causing the CPU to self-immolate or whatever. So that means the performance opportunity for you is not to dump more power into the CPU. Intel's already doing that, but you can dump less power for the same performance, or maybe get more performance for the power that you're already putting into the CPU, if that makes sense. And that's what XTU is doing for us. So yeah, it's pretty awesome in that regard. So restating all that another way, for the same power that the system was using out of the box, 6.1 gigahertz was achievable without too much headache, and just shy of 1,000 points in the CPU-Z benchmark. So single thread performance, kind of nuts. You've got to choose a motherboard. Carefully picking a motherboard for your LGA 1700 processor has always been important. Even if you don't have a K-series overclockable CPU, how much power you can dump into your processor via your motherboard can affect both the peak performance as well as the multi-core performance of your CPU. The good news is that as long as your motherboard maker certifies it, these 14th generation CPUs should just drop right into your Z690 and Z790 motherboards with an LGA 1700 socket. 660, 660M, that's basically true. This is the Gigabyte B660M DS3H, although I wouldn't recommend this one. More on that one in a second. Generally, though, these 14th gen CPUs should work on your existing Z690 and Z790 motherboard, assuming that it gets the update. And there are some deals to be had on Z690 motherboards, but not so fast. There's really two gotchas. The first is that if you have an older motherboard, it might not post with a newer CPU. The motherboard's got to have some sort of USB BIOS flash upgrade capability, BIOS flashback, whatever, in order to support a newer CPU. Be sure to see our other videos on that, or hit us up on the Level 1 forums. If you have to borrow someone else's CPU to get it going, that's another option, so you can put in an older CPU and upgrade your motherboard to support a 14th gen CPU. But then the other thing is power delivery. Does your motherboard support the proper power delivery? In the past, I've warned about power delivery, such as on this motherboard. It's okay, but even with the i5 K-series processor, this motherboard can't handle the sustained loads without throttling unless you're really, really careful about your build and a bunch of other details. The power delivery needed for 14th gen to really unlock it, or at least if you're going to overclock, or at least just to let it self-boost as much as possible, is sort of important this time around. Now the good news is that for motherboards that were already high-end, like the Z790 Godlike, or the Z790 Taichi Lite, which is actually a newer version of the Z790 Taichi that's more cost down, these motherboards are fine. It's really just these other motherboards. And sometimes the B660 motherboards, like, okay, this is the Steel Legend B760M. This is a pretty good choice for the i5 14600K. But the B660 version of this that does DDR4, you might want to wait a little bit longer for that one to get an update, because DDR4 with 14th gen CPUs, at least in the two boards that I tried it in, was not perfectly stable. Not sure what that's about. It should work though. Now, if you're used to using Hardware Info 64 and you bring up Hardware Info 64 on our Taichi Carrera motherboard we use for our testing, you'll see that it says PL1 and PL2 power limits 4 kilowatts. Now, obviously, the motherboard's not going to deliver 4 kilowatts, but we did sort of move from 275 watts to about 350 watts with up to 400 amps with this 14th gen CPU. And the current limit is the variable you want to look for, which is called different things on different boards. CPU current limit, core current limit. It's usually something measured in amps. Well, it should be measured in amps, but in your motherboard BIOS, it should be in amps. And sometimes that's set for like 280, 300. You want it ideally to be 400 with 14th gen CPUs, especially if we're talking about the 14900K. Obviously, if you're rocking the i5, the i5 is not going to care as much about delivering 400 amps to the processor, but you also don't want to leave any performance on the table. That is assuming that you can keep it cool. Consider also refresh motherboards like our Z790 Nova Wi-Fi, and pretty much anything with Wi-Fi 7 is going to be updated. So in addition to Wi-Fi 7, this is an 8-layer printed circuit board. It has 6 M.2, but really it's around the power delivery. This thing is set up to deliver more power. And the other consideration is the memory speed, like I was saying. So DDR5 7800 mega transfer memory. For my own testing, DDR5 6400 was rock solid right out of the box, and I did try up to DDR5 7200 and was pleasantly surprised that it's basically plug and play at this point. Between BIOS updates and physical motherboard updates and overclockers and all of the stuff that's going into DDR5, support for things that are beyond DDR5 6000 megatransfers is basically table stakes at this point on these newer motherboards, which is amazing because in the beginning it was not like that. So for that and it's like, don't be tempted to put a 14th gen CPU in a DDR4 platform. You're leaving performance on the table, first of all. But second of all, look how far we've come. The updated Steel Legend motherboard, if you're on a budget, you've got options if you're on a budget. You don't have to go with DDR4. Just consider the power delivery, especially if you're going to do an i7 or an i9, and consider the DDR5 memory speeds. You also probably want to get a newer DDR5 memory kit. Maybe don't be tempted by an old stock DDR5 memory kit that is mysteriously less expensive than other ones. Now, obviously, if you sprung for a more expensive Z790 motherboard to begin with, you're not going to need another updated Z790 motherboard. In fact, if you already have a 13th gen processor, what are you doing looking at upgrades? Just wait. Obviously, if you have anything 12th generation or newer from Intel, it's probably not enticing for you to upgrade. If you've got a 12th generation i5, okay, maybe, and your CPU cooler is good enough, you could drop in one of these with a BIOS upgrade. Yeah, I could maybe get on board with that kind of an upgrade, but you'd be moving from an i5 to an i7 or an i9. If you're on anything older than Intel 9th gen, or pretty much any AMD AM4 CPU, except maybe the 5800X3D, you might be looking at something in LGA 1700 for an upgrade, not necessarily 14th gen. You see, the disruptive thing here is that Intel is facing a lot of competent competition from AMD. I don't think anyone at Intel expected AMD to do as well as they did with their 3E V-Cache parts, especially the 7000 series Ryzen desktops. And yet, for many scenarios that benefit V-Cache, the memory and clock speed advantage you're going to have from Team Blue are giving the edge to Intel in the tests that we're running with the highest end 14900K configurations. So while the front part of Intel is releasing 14th gen with 14th gen pricing and naming it 14th gen, I think so as not to spook investors. In the back, Intel is very aggressively pricing 12th and 13th gen parts to drop into existing LGA 1700 motherboards. So they're trying to disrupt things in the front and the back. For gaming scenarios, you'd hardly notice any differences going from an i7 12700K gaming system with a GPU that costs $800 or less to a 14th gen. But if you have a $1,000, $1,500, $2,000 GPU, then okay, you're going to start to feel the difference here. Oh, and to be sure, I think AMD notices that Intel is very aggressively pricing things in the 12th and 13th gen because AMD's pricing around AM4 has also gotten nothing short of insane. I mean, $100, $200 for 5000 series AM4 processors. But, I mean, it's still last gen technology, still DDR4, it's still older stuff. AMD is probably going to have to get even more aggressive because of the $300 i9 12th gen, for example, assuming that's in your market. Oh, and special shout out to Intel for the Arc A770. The A770 is a great GPU to pair with the i5 14600K. It's probably come farther with software updates than any GPU that I've ever laid my hands on, and how Intel engineering is approaching the let's bring up a gaming GPU in 2023 from nothing is nothing short of spectacular. The fact that gamers are going to have more options in the market, monoculture is bad for gamers, and the Intel roadmap to becoming a major player in the GPU space is very exciting, especially if Intel will follow through. Now for that i7 CPU I mentioned before, in particular, I'm excited about it. I actually reached out to Falcon Northwest to ask them a whole bunch of questions, and long story short, they're going to send me an i7 14700K in one of their frag boxes because I wanted to do some benchmark testing specifically on it. Look for that later this week. I can't wait. Games mostly use the performance cores, the P cores, but the i7 still has 12 efficiency cores. Oh, and if you don't have room for a 420mm cooler, you're doing the small form factor thing, I think the i7 is likely to perform better than the i9 because it's going to be more power efficient. More efficient means less power and less heat to get to a given level of performance. So, level 1 predicts SFF building around the i7 versus the i9 in gaming scenarios, the i7 is going to outperform the i9 because of the cooling and power delivery. All in all, this is a pretty modest CPU launch. There's not a huge upgrade over their predecessors from 13th gen. I mean, the performance has improved, and performance per watt, if anything, is a bit worse. But lightly threaded desktop performance that we've seen is the fastest lightly threaded performance you're going to get. I mean, 6 to 6.1 gigahertz on the desktop, achievable by anyone as long as you've got top shelf cooling. I mean, it's kind of a watershed moment. 6.1 gigahertz on the desktop without a lot of fuss. It's pretty cool. I'm Wendell, Level 1, and I'm here to tell you that the processor war is very, very good for consumers. Whether you're after peak performance or peak for efficiency, there's an option for you. And that's pretty exciting. I'm signing out, and you can find me in the Level 1 forums.